In 2020, the massive commercial success of Chinese global software exports highlighted a shift that Western defense analysts are only now fully processing. China's software engineering ecosystem had quietly become world-class. Behind the multi-billion-dollar commercial rendering engines, real-time physics models, and massive network-synchronized environments developed by tech giants like Tencent and NetEase lies a deeper structural reality. The computational infrastructure required to simulate complex real-time fluid dynamics, multi-agent behavioral AI, and synthetic environments at a civilian market scale is functionally adjacent to the software architecture beneath military-grade virtual reality systems. Through Beijing's strict civil-military fusion doctrine, this immense commercial talent pool and software pipeline are structurally permeable. The question worth asking in 2026 is not whether China can build a submarine simulator. The question is whether they have leveraged this hyper-scalable civilian tech ecosystem to build a synthetic training architecture so advanced that the United States Navy has no operational equivalent. The real question: does the PLN actually use simulators? The short answer, based on available open-source intelligence, is yes, and the program is larger and more systematic than most public reporting suggests. The People's Liberation Army Navy have operated physical mock-up trainers and combat system simulators for decades, but the doctrinal shift came in 2014 when China's military strategic guidelines formally mandated a transition toward what Beijing called informationized warfare and intelligentized combat systems. Shore-based trainers became full mission simulators. Full mission simulators began incorporating real acoustic data collected from operational patrols. By 2018, when Xi Jinping visited the Qingdao submarine base and walked directly into the comprehensive simulation facility, the program was already past its experimental phase. It was standard doctrine. This is not a screen and joystick. PLN submarine simulators are full-mission replication environments that model the reactor compartment, sonar console architecture, fire control systems, and the acoustic environment of the operational platform being trained. For the Type 093B, China's most advanced nuclear attack submarine, displacing approximately 6,200 tons with pump jet propulsion and a 12-cell vertical launch system capable of deploying YJ-18 or YJ-19 hypersonic missiles and maybe YJ-21. The simulator replicates cavitation behavior at varying depths, thermal layer interactions with passive sonar, and the thermal loop management required to suppress involuntary noise transients during high-stress tactical sequences. Acoustic signature data collected by Y-8Q anti-submarine patrol aircraft operating across the South China Sea and Western Pacific is fed directly into the training environment, meaning crews are not practicing against generic threat models. They are practicing against the actual sonar signatures of the ships they will one day face. Here is the what-if that keeps undersea warfare strategists awake. What if the PLN has been running Type 093B crews through simulator-based combat scenarios for 3 years before those submarines ever left the shipyard? What if those crews have rehearsed hundreds of times the exact acoustic conditions under which a Virginia-class SSN's AN-BQQ-10 passive sonar array begins resolving a pump jet signature, and have drilled the precise speed-depth heading combination required to stay below that detection threshold? What if the first time a Type 093B shadows a U.S. carrier strike group in the Philippine Sea, its commanding officer has more simulated deep-water combat hours logged than a newly commissioned U.S. submarine skipper has actual sea trial hours? These are not hypothetical provocations. They are the logical downstream consequence of a simulator doctrine that compresses experience through algorithmic iteration at a scale and speed that conventional at-sea training simply cannot match. The connection between commercial software development and advanced military simulation is structural, not analogical. The underlying mathematics required to render high-fidelity graphics, simulate complex fluid dynamics, model acoustic environments, and synchronize massive multi-user networks at a commercial scale are functionally adjacent to the physics modeling demanded by high-tier military simulation. Over the past 15 years, China's domestic commercial gaming and tech sectors have solved these exact computational challenges at an immense civilian investment scale. While the United States historically constructed its simulation infrastructure through highly specialized, high-cost defense contracts, Beijing leveraged an asymmetric economic model. By fostering a hyper-competitive civilian software industry, China built a parallel technological infrastructure funded by global commercial revenue. Under the formal mandate of the Civil-Military Fusion Doctrine, the boundaries between this civilian engineering talent pool and state defense programs are intentionally permeable. The institutional knowledge, real-time physics engines, and algorithmic frameworks developed for the commercial market are systematically re-engineered for strategic military applications, providing the PLA with a highly scalable, self-sustaining software pipeline that operates independent of traditional defense procurement constraints. The PLN faces a fundamental arithmetic problem. Between 2021 and 2025, it commissioned an estimated 7 to 8 Type 093B hulls, a production rate that would have required a pipeline of fully qualified nuclear submarine crews that did not exist under conventional training timelines. The United States Navy requires approximately 5 years to develop a fully certified nuclear submarine crew from initial pipeline entry to independent operational deployment, and that timeline reflects genuine operational complexity that cannot simply be legislated away. China's answer to this problem is not to compress the sea trial phase through shortcuts. It is to front-load proficiency acquisition through simulator-based pre-qualification, so that a crew arriving at the pier for their first underway period has already accumulated hundreds of hours of high-fidelity tactical experience in the synthetic environment. The result is a 3-crew rotation model applied against individual hulls, dramatically increasing the operational availability of each commissioned platform without requiring additional construction. Analytical integrity demands an honest accounting of the ceiling. No simulator, regardless of its fidelity, can replicate the psychological attrition of 90 days submerged in a pressure hull with 40 other human beings under sustained operational stress. It cannot model the specific mechanical failure patterns of real mechanical systems under sea-state conditions, the judgment degradation that accumulates across weeks of sleep disruption, or the command decision-making that only crystallizes when the consequences of a wrong choice are genuinely irreversible. These are not minor gaps. They are the variables that determine whether a crew performs to its simulator-trained standard or collapses under the weight of conditions the synthetic environment never presented. The PLN simulator program almost certainly produces crews that are more technically proficient faster than any previous Chinese submarine training pipeline. Whether it produces crews that are operationally equivalent to U.S. Navy submariners with genuine deep water experience at scale remains the unresolved question. And it is unresolved precisely because the relevant data is classified on both sides. Here is why this matters at the strategic level in 2026. The United States Navy's undersea dominance has historically rested on two pillars: superior platform technology and superior crew proficiency developed through decades of accumulated operational experience. The technology gap is narrowing. The Type 093B's pump jet propulsion and anechoic tile coating have materially closed the acoustic signature differential that once made PLAN submarines straightforwardly detectable. If the simulator program is succeeding at the scale Beijing's investment suggests, then the crew proficiency gap is also narrowing, not through sea time, but through synthetic experience at industrial scale. The scenario that represents the genuine nightmare for U.S. Navy planners is not a single Type 093B defeating a Virginia class in a one-on-one engagement. It is a PLAN with 15 to 20 operationally proficient attack submarines, crewed by personnel who have logged more combined simulator combat hours than the U.S. Pacific Fleet's entire SSN force has logged in actual patrols, positioned across the first and second island chains simultaneously. At that point, the United States no longer faces a capability deficit to manage. It faces a presence deficit that no amount of technological superiority can fully compensate for. The multi-billion-dollar global revenue generated by Chinese commercial software and gaming exports is not strategically significant because of entertainment metrics. It is significant because of what it indicates about Chinese software engineering at scale and the institutional human capital pipeline that commercial dominance creates. The software engineers who build highly complex real-time physics simulations, low-latency networked multiplayer architectures, and massive procedural environments operate within the exact same national talent ecosystem that the PLA simulation and cyber development units draw from. When Western analysts assess Chinese military simulation capabilities, they traditionally limit their scope to formal defense budget line items and declared state programs. This creates a critical intelligence blind spot. The complete strategic picture must include the commercial software sector as an industrial accelerant, a massive, self-funding civilian investment pool operating at a scale no traditional defense budget can match, continuously advancing the foundational technologies upon which modern military simulation depend. China is not building a military that simply borrows from its commercial sectors. It is executing an integrated national capability ecosystem in which the structural distinction between civilian software engineering and strategic military application has been deliberately and permanently eroded. The undersea balance in the Indo-Pacific is not going to announce itself when it changes. There will be no single event, no dramatic demonstration, no public acknowledgement from Beijing that its submarine crews have crossed a proficiency threshold that alters the strategic calculus. It will simply become apparent in the geometry of deployments and the confidence of maneuvers that the PLN's undersea force is operating with a competence that its sea trial history alone does not explain. The simulator program, built on a doctrinal foundation in 2014, accelerated by a command directive issued in 2018, and enabled by a commercial software ecosystem that produces world-class simulation engineers at civilian market scale, is the most plausible explanation for how that transition happens without the United States seeing it coming. In undersea warfare, the most dangerous adversary is not the one that announces its capabilities. It is the one that has been quietly rehearsing your defeat in a room you cannot see, on a platform you underestimated, with crews who have already beaten you 100 times in a world you never knew existed.